I guess the weather scared everybody off tonight. It says you need to change your video resolution. Yeah, I know. I mean, that was there last week. I don't know why that was there, but anyway. Okay, I think we're on, except for the information about changing the video resolution, which we have to ignore. What? Okay, so tonight we're going to talk about two things. Next week we're going to talk about a couple of actual file systems, FAT and NTFS. And then the week after that is a midterm, as I recall. If it's not, it's the week after that, but I think it's the week after. I think it's 2 weeks from tonight. I can check that actually in a little while. But so tonight we're going to talk about basic MBR partitions and then follow that by GPT partitions. And I'm going to talk about basic MBR partitions first. And a lot of what I say during that is going to be consistent with GPT partitions, because there's a lot of things that are the same, although there are significant things that are different. So anyway, so this is basically Carrier's Chapter 5. And a lot of what I do is going to have slides that look very much like the diagrams in Carrier's book. And there's a bunch of additional information as well. So there are today two different types of disk organization: basic MBR, where a partition schema that began in the early 1980s, maybe even probably 1981 or 1982. It's been around for half a century or thereabouts. It's still widely used. I say the most widely used. Well, it's losing ground to GPT partitions, but it's still used a lot. And especially for forensic purposes, you run into it quite a bit. And then there are GPT partitions. And this is a partition schema that was developed by Intel and began around the year 2000. It eliminates some of the limitations of basic MBR. It was originally used on servers only, but now it's increasingly used on client systems. And in fact, most Windows client systems that you would get today use GPT partitions. Although I ran across one just recently that had, they used basic MBR. It had the GPT overall format, but it used basic MBR partitions. So let me give you a little bit of an overview. The basic MBR partitions are what is sometimes referred to as PC-based partitions, is one of a number of different schemes that's used for personal computers and the servers as well. For basic MBR partitions, you need BIOS code in the firmware to get things going. GPT partitions, however, don't use BIOS code. They require the use of EFI or extendable firmware interface code. And I'll talk more about that later and talk about what can be used and what can't be used. Basic MBR partitions are used on hard disks and diskettes, some but not all thumb drives. In fact, one of the reasons we talk about it is because a lot of the drives around, not things that boot operating systems and stuff, but things like CDs and DVDs and zip drives and everything else, they all use basic MBR partitions, even to this day. Now, one of the other terms that's used to refer to these is sometimes called DOS partitions. And that's just historical. It's really refers to the DOS operating system from many, many moons ago. Carrier uses this term in the book, however. So whenever you run across DOS partitions in Carrier's book, this is what you're talking about. Now, there's no official standard or specification. There's a lot of things that claim to be accurate, but there's no official, and I don't know who would offer an official standard or specification at this point. So that's maybe one of the reasons there is none. Operating systems that use basic MBR partitions include those and many others as well. Like I said, it's been used since the beginnings of the IA-32 systems in the early 1980s. It was originally designed for the needs of PCs at that time, small disks and very few partitions. It has been modified to accommodate today's disks. It can now accommodate much larger disks and many partitions. In fact, the way they did it, because of linked list structures that they put into the firmware, you can have an infinite number of partitions. However, it caused MBR partitions to become somewhat convoluted. And while not bad once you understand what's going on, it's something that maybe you gotta get your brain around a little bit. And that's part of tonight. We will talk about that. So we will focus on basic, not dynamic partitions. And by that, I'll explain what I mean by that in a minute. And we will focus on MBR, not GPT or other partitions. That's for this slide set. There's a second slide set tonight that will focus on GPT. So the PC-based partitions that we will discuss here are basic MBR partitions. Now, I keep using these terms interchangeably, and unfortunately that's because they are used interchangeably. And you're going to run across them all. And so just be aware, and you know, in particular, Brian Carrier uses the term DOS partition when he means that. However, as I said before, a lot of what we're going to talk about tonight and some of the demos and other experiments that we will do tonight are going to apply to them both. And so it's one, because you need to understand that these things are around, especially for purposes of cyber forensics, and also because they apply to GPT partitions as well. It is perfectly reasonable, in my opinion, to start out by talking about those, and you will see then we will transfer over to GPT later on in this lecture in a second set of slides. Now, basic and dynamic partitions. Well, basic refers to consistent or contiguous sectors on a single disk. Dynamic partitions are those that can be comprised of smaller non-contiguous sections which become dynamically associated as the need arises. So what's the organization? In Carrier's terms, the DOS partition organization. Now, one of the things about the original basic MBR partitions is the maximum number of partitions. You can have up to 4 primary partitions. Now, I emphasize the word primary because when we get Carrier uses terms primary and secondary partitions, and you got to keep that clear in order to be able to figure out what's going on. And the reason for this is a hard limitation. It's limited by the fact that there is space for four partition specifications in the master boot record partition table. There's only room for 4. So that's a hard limit. Now they found a workaround, which we'll talk about. But in terms of primary partitions, and I will discuss what that means a little later, there can be only 4. And obviously, when you got to the point where you wanted more than 4 partitions, this was a problem. So they had to modify the scheme. And this led to much of the complexity that we'll discuss later. So, master boot record. All basic MBR partitions have a master boot record in the first 512 bytes sector of the volume. Volume being used exactly what we talked about last week. Sometimes it's called the volume MBR. It's located in the first sector of the volume. That's LBA sector 0. And the master boot record contains, for the volume, the boot code, we talked about that last week, and a partition table. And then the signature value at the end, which is hex 55AA. Now, you saw diagrams last week that we talked about that, and so I'm not going to repeat those, but the boot code is in the first 446 bytes of the MBR. Now, the code can be extended into sectors 1 through 62 as needed, because if you remember, those sectors are always reserved. And often they're just empty. The code processes the partition table, locates the partition in the and in addition to the formatted MBR, there is the boot code. In addition to the boot code, there is the partition table, which are in bytes 446 through 509 of the first sector. And it defines up to 4 partitions. And then there's the signature value. So one way to think about this is that there are 3 things in the formatted MBR: the boot code, the partition table, and the signature value, which is 55AA. Now, I'm going to kind of be moving back and forth, so I'm going to what I'm going to do is I'm going to do this. And you know what I should do, which I didn't do because I was running out of time, and I apologize for this. Maybe I'll take the time right now to turn this into a PDF and put it on Blackboard because, well, let me do this one and then I'll take the time to do that. So if you go to your Radish NG 538 desktop and you open WinHex, which you did last week, and you should be able to see something that you had before. So let me do that. Okay, so I'm going to open this guy. Now I got a bunch of garbage here. But if I open this thing as administrator, WinHex, and if you get this thing, hit start as a new instance, just because it's probably going to be the same as what you had before. And you're going to get WinHex, and then you're going to go to Tools, Open Disk, and you're going to want to look at HD0 in this particular case. And if you're going to open that up, you're going to see this. Now, I'm going to close this up for the time being, and all we have is the start sectors. And what you're going to see, here is 55AA down here. But here, starting here and going to here, is the partition table with 4 entries. Each entry has 15 bytes, 16 bytes in it, sorry. And the only reason I know it starts there is because of the fact that I counted back 4 times 16 from 55AA. So this is, and the idea was most everybody did this last week, and the only reason I had you start a new instance is just so that you do it again, I guess. And if you open it up, you can delete files that were already there. And let me, no, that's not what I want to do. Clicked on the wrong thing. If I wanted to delete a file, I would right-click on the tab and then close it, and that deletes it in WinHex. So you could have multiple tabs out here with multiple things, and then if I click on the tab, right-click on the tab, I can close it. So that's the other way you can do that. And it says so right here. And this is what I did before, and this is what you would get. And if you look at the first sector hard disk, which we looked at, and the reason you know it's the first sector, it contains the master boot record. And here we are, which is exactly what I showed you. So if we want to animate this, actually I don't know if we can animate it. I can put the lines around it. Gee, I even animated that a little bit. And then this is this is the partition table with 4 partitions in it, 55AA at the end, and everything from here down to this point is the boot code. And there's always an error message at the end, because if it can't find a valid partition in an operating system, you get this message out. So now here's another hard disk. It's one more like the one you might have on your personal computer if you're using basic MBR partitions. And lo and behold, it looks not too dissimilar. So the MBR partition table has 4 entries. Each entry describes a basic master boot record partition, or DOS partition. And this DOS partition, or this one entry in the table, contains the following fields. It contains a starting CHS, cylinder head sector address. It contains an ending CHS sector address. And you remember we got rid of CHS sectors in the ATA command set a while ago already, but they're still around. A starting LBA sector address, the number of sectors in the partition, the type of partition, and flags. And I'll talk about what some of those mean.
So the CHS is included even if it's not currently using it?
CHS is currently there even if it's not using it. Now, there has been an argument for quite a while now about the fact that rather than go to GPT, and there are some reasons to go to GPT, but rather than go to GPT, it would have been just more reasonable to flush CHS. It gives you a lot more space, and then you can use it to overcome many of the shortcomings of the basic MBR partitions. And I think I have a little bit on the slide about that a little later. So this accommodates legacy CHS systems, which are less than 8 gigabytes. This works for everything else. That's the type of partition generally specifies a file system or other information about what's in the partition. And the flags, typically the only flag that's around is which partition might be bootable. And if there's more than one bootable partition, typically then there will be additional code in sectors 1 or more, which allow you to make a choice about which one as a user you want to boot up. And I think I even have a slide on that a little later. So here's an example. This is right out of Carrier. So here I have a volume. And here I have the basic MBR partition, and one of them points to partition 1, and one of them points to partition 2. That's the MBR partition table there. The unused entries are there, because there's only 2 here. So they're just unused. And typically what's in them is a bunch of null characters. Now, with regard to partition type, the partition type, as I said, describes what's in the partition. Typically, you'll find things like FAT12 or FAT16 or FAT32 or NTFS or Linux swap or Mac OS 10 or VMware swap, etc., and ad nauseum and ad nauseum and ad nauseum. I have a list later on which lists even more of this stuff. But those, and all of those items, you don't see letters like FAT12. What you see is a number, because there is a number, the numbers have been defined for each of these things, and you will see that that's true. For Linux, well, anyway. Now, Windows operating systems use the type of field to decide how to interpret the contents of the partition and how to mount it. And by simply changing the type field to a partition type that Windows doesn't support, Windows won't mount it. So therefore, by changing the partition type that Windows does not support, for instance, you might give it a Linux partition, a whole partition can be hidden from the Windows operating system. Now, other operating systems, such as Linux, don't rely on the type field. If a FAT32 partition has its type field set to Mac OS 10, Linux will still mount it as FAT32, even though it is not listed as something that is mountable. Windows won't do this. It just won't mount it. So here's an example of 4 partitions. There's the MBR. So here again we have the volume. I show 4 partitions. I show the master boot record at the beginning, just before partition 1, and there's some unused space at the end. And so, we're limited to 4, and this needed to be fixed. So the concept of an extended partition was introduced. Now, I've tried to be exactly precise in my color coding of the characters for things like extended partitions and by primary partitions and secondary partitions. Primary partitions, whether they be extended or otherwise, are blue, and secondary partitions are green for the rest of these slides. And Carrier doesn't do that because there's no color in his book or anything else. And when you read it, it gets confusing. And so hopefully these slides will help you figure out what the hell he's really saying. So what's an extended partition?
So the MBR is going to be in the same box with the number 4 partition, yeah?
I'm sorry, what?
Could you go back just for this slide?
Okay.
Yeah, see the number 4 partition?
Yeah.
It's going to be in the same box with the MBR, yeah?
Yes, each one of these partitions has a entry in the partition table of the master boot record.
Oh. Isn't the one before it was different, yeah?
Well, there wasn't any. You're talking about this one? Well,
Yeah, here.
yeah, well, because these are, the colored ones are unused.
Oh, okay.
If you only have 2 partitions and you got room for 4,
You don't have it.
okay, let me move forward. Okay. So you have a master boot record with, and in this particular example, there are 4 partitions. Okay, but that's the end. That's the end of the ballgame. It's a hard limit because of the space allocated for the entries in the master boot record. And so we need to do something about that. And so the concept of an extended partition was introduced. So what's an extended partition? It was a solution to the limit of our partitions, and the way it works is as follows. But I'm going to have to define some things first in order, because now, and the way Carrier does this is a little confusing, and you have to sort of figure out what's going on. And I think if you read Carrier's book and you look at these slides at the same time, you can, and maybe even get colored highlighters, so you'll know what the hell he's talking about.
Good look if you're reading it online, you know. Get too much in your screen.
Right. Anyway, these are important definitions in order to be able to understand what's going on. There's something called a primary partition. A primary, and Carrier refers to this as a primary partition, but he doesn't put it in blue. And so there is a primary partition. It's a partition that has an entry in the master boot record. A primary partition has an entry in the master boot record. If it doesn't have an entry in the master boot record, it's not a primary partition. There are 2 types of primary partitions, however. There are primary file system partitions, and these are primary partitions that define a file system. And there are primary extended partition. There is a primary extended partition, which is a primary partition that contains additional partitions. And this was the workaround. So the word primary equates to an entry in the MBR. And you need to keep that in mind. And that there's even a further complication beyond this, but let me go on. So here we have a disk with a primary extended partition. I have 4 partitions again. 3 of them are primary file system partitions. And 1 of them is a primary extended partition. And there is an entry for it in the master boot record. And the file system type, the type of entry is that it's a extended partition. So, okay, so that's a primary extended partition. And it points to the entry for the primary extended partition is there, and it points to the primary extended partition. Now let's talk about extended partition a little bit further. An extended partition can be thought of as a container or a wrapper for an additional partition. Extended partitions have extended partition boot records in their first sectors, just like the master boot record. They kind of are like a master boot record, sorta. An extended partition can contain 2 partitions. Not 4, but 2. Even though there's space for 4, because the format is exactly like the master boot record. It's just that it's someplace else. It's in the extended partition. And so an extended partition can contain 2 partitions. It can contain a file system partition, which defines a file system. And it contains an extended partition. So the extended partition, it contains an extended partition. As I said, extended partition boot records are very similar to MBRs, but don't confuse them because they're used differently. Okay, let me go on. So far, everything's blue. A primary extended partition contains 2 partitions. A secondary file system partition, notice it's green, also called a logical partition, and a secondary extended partition, also green. Why are they green? Because they don't have entries in the master boot record. They have entries in the primary extended partition table, which looks like the master boot record, but isn't. Yeah, I know. And Carrier talks about all this, and he uses the terms, but he doesn't have colors. I didn't know whether colors are the right solution, but I had colors, so. Now, some more definitions. A secondary file system partition is a partition within an extended partition that contains a file system. And a secondary extended partition is a partition within a primary extended partition or a secondary extended partition that contains additional partitions. Now, there will be a couple examples that will maybe make this a little clearer. So the word secondary equates to an entry in an extended partition boot record. So primary equates to an entry in the master boot record. Secondary equates to an entry in the extended partition boot record. So that's maybe the simplistic way of thinking about it. If it doesn't have an entry in the primary extended partition, if it doesn't have an entry in the master boot record, it's not blue. Primary, think MBR. Secondary, think extended.
It's so clear. I
What?
think it's so clear to understand.
Well,
The color is not clear.
if you read Carrier's book, it's not clear because he doesn't have colors or doesn't have any other way of. He doesn't distinguish them. He knows what he's talking about. It took me a while to figure out when I read the book many years ago what the hell he was talking about. But that's what he's talking about. Okay. Example. Hopefully this helps. Suppose that you have a 12 gigabyte. I'm going to change that. Supposing you have a 12 gigabyte volume. You need 6 partitions, each of 2 gigabytes. So the volume is big enough to handle it. So what do? You can have only 4 primary partitions. So what do? Well, you could create 3 primary file system partitions and 1 primary extended partition. So here, this is what we might do for starters. So I have a primary file system partition, points to this file system. I have another primary file system partition, points to this one. I have a third primary file system partition, points to this one. And I have a fourth primary system partition that is an extended partition that points to the rest. Now, so what do you do with that? Within the primary extended partition, create 1 secondary file system partition, because I want 6 partitions. They each have a separate different file system in them. And then 1 secondary extended partition. So I could do this. Within this, I could create another. I now have a extended partition table in here. Looks very much like this one, but it's not. And it points to 2 things. It points to a file system partition and another extended partition number, I'll call it number 1. Now this is the primary extended partition. It's primary because its entry exists in the master boot record. And this is secondary because its entry exists in a primary extended partition. So, okay, so.
Could you repeat that, please?
Pardon?
Could you repeat the point? I didn't understand that. The difference between the primary and extended.
This one is a primary extended partition because it has an entry in the master boot record. This one has an extended partition in here because it has an entry in the primary extended partition table, which looks very much like these, except they're not. So now we have 4 partitions that contain file systems that can contain operating systems or other data. So what's next? So we could create within the secondary extended number 1 another secondary file system partition, a file system partition number 2, and also create 1 secondary extended partition number 2. So now we have that. Now notice, I don't want to get there yet. So now we have 5 partitions. We wanted 6, we only have 5 that contain operating systems or other data. What's next? We can create within secondary extended number 2 a secondary file system partition number 3. And now we have the 6 partitions we needed.
Why didn't they have in the secondary file system partition, why didn't they just make it 4? They've got, you only able to have 2 entries.
Yes, they could. And the answer is I don't know, because I was probably still in diapers when they were doing this. Well, not quite, but anyway, I don't know. But my guess is that this is you realize that you can do this forever.
Yeah.
And so this was a single algorithm that allowed you to get as many partitions as you wanted by simply iterating in a single process. Now that's Wodzinski's guess about why. Yes, you could have done something like this.
So why do you have to do the third one as well? If you're the second, number 2 identifies 2 partitions.
You could have put 2 in here, but that would have violated the rule. Yes, I don't disagree that you could have actually put 3 in here and just said, okay, we're done. Because you have the room here to do that, but they chose not to do it. And so this is the way it's done. So at the cost of an additional extended partition boot record per file system partition, you can have as many file system partitions as you want. No limit. Goes on forever. Now, how about the capacity of extended partitions, secondary extended partitions? An extended partition table should have at most 1 entry for a secondary file system partition plus 1 entry for a secondary extended partition. 1 of each, and that's all. Carrier writes the following. He says, most operating systems will not generate an error if more than 2 entries are in the secondary extended partition table. He said he created a disk with a primary extended partition that had in it two secondary file system partitions plus 1 secondary extended partition. So he had 3. He had 2 file systems and another extended. And he reported that some forensic tools properly handled the 3rd partition entry, and others ignored it or claimed that a 25 megabyte partition was a 1 terabyte partition. Because they were following the rules, and this thing he created violated whatever they were doing. So, extended partitions have special types that are used in the partition table type field. So for instance, you have Microsoft Extended CHS, you have Microsoft Extended LBA, Linux Extended, et cetera, et cetera, et cetera. You have different types of extended partitions. And there are several kinds. However, there's a problem because there is no type field differentiation between primary and extended partitions. So we don't know when we look at one which is down the chain a ways whether it's primary or secondary. And this is part of the confusion that when he reported what he did in the other scheme, where we had two partitions and the two secondary file system partitions. that I suspect one could suspect that whatever tool found was reporting things wrong was assuming something about being a primary rather than a secondary partition. But just using the type fields, it's hard to know what's really there if you only use the type fields to do the analysis.
So you're saying that you might actually put a secondary file system? No, you had, before the example, you had primary, and then you do like the secondary. Could the secondary be primary, primary?
The answer is, I don't know, I've never done that, but I can't imagine why it wouldn't be. But I've actually never done it. What I've done is I've done what the canonical way to do things.
Yeah.
When I run out of primaries,
Right.
I put in an extended, and then I work from there.
I just didn't know if that was one of the reasons that you can get lost easily when you look at it because you don't know.
And that's true. I don't. So the question basically was, could I have a primary partition, file system partition, then an extended file system partition, and then, a primary file system partition, then a primary extended partition, and then another primary file system partition? And the answer is, I don't really know. Let's look at the boot process. Remember, the MBR boot code is in those bytes of the first sector 0 of the volume, but it can extend into up to 63 sectors as needed. Bytes 446 through 509 of sector 0 contains a partition table, room for 4 primary partitions. Boot code examines the partition table to see which partition has a bootable flag set. One of the things that might be true about what you were asking is that there isn't a lot of room there for code. If I want to stay in just that code, I don't have a lot of wiggle room. I would have to go into some of the other sectors and have additional code there to analyze the master boot record to say, okay, what's really going on here? And you could do that. That's not an unreasonable thing to do. And there's software around that does that sort of thing and allows you to do multiple boots, and I don't see any reason why it couldn't be coded to make that work correctly. It just doesn't seem to me. So what does the boot code look for? It looks for the boot flag in the first byte in one of the primary partition table entries. It finds a bootable partition and determines that the locations of its. Then what it does is it finds so the boot code runs around and looks for a boot flag in one of the entries. It finds a boot flag. It's in the first byte of one of the primary partition table entries. And it says, oh, okay. And then I have the CHS and the LBA locations. And so for that bootable partition. And so then what I do is I load the program counter with the address of the very first byte of that partition, and I jump to it and start to execute. And now I'm out of the master boot record completely. And I've now got control of the bootable partition. So if I have multiple operating systems, you can install them using this scheme. So how? Well, a boot time, a choice can be made as to which operating system will run. And there are currently two approaches, and this is fairly important because the two approaches are different, and Microsoft, of course, does one, and everybody else does the other. There's Microsoft's, and there's everybody else's.
So it always is, right?
Of course. When IBM was king of the hill, they did that too. What can I say? So the Microsoft approach goes something like this. The MBR code is executed normally, identifying a bootable partition. Boot code exists in bytes 0 through 445 of sector 0. The MBR code loads the code, and that is in the bootable partition. The computer executes this bootable partition code. So basically, the bootable partition code. Now, so what happens is that the boot code in the MBR finds a bootable partition. It goes to that bootable partition, loads code at the beginning of the bootable partition, and then executes that bootable partition code. Now we're far away from the master boot record already. And then typically at that point in time, the user is prompted by the bootable partition code to choose an operating system. Now there's Microsoft and a lot of their Windows operating systems use a piece of software called boot.ini, which basically give you a text command which saying, here are your choices, pick one. And you picked one. So maybe I want to boot Linux, or I want to boot Windows. So the user chooses an operating system, and the computer jumps to the first byte of the first sector of the selected operating system partition. Same deal, same process again, except we're no longer anywhere near the master boot record. We've transferred control originally to something that the master boot record said go to, and in there you have the additional information. So this approach allows operating systems to boot from non-bootable partitions, meaning that they are not listed as bootable in the master boot record. There's another approach. Master boot code is in bytes 0 through 445 of sector 0, and that code is modified. And typically more MBR code is usually added in sectors 1, 2 as needed. And the newbie MBR code prompts the user to choose the operating system code right in the master boot record area. User chooses an operating system. Computer jumps to the first byte of the first sector of the selected partition. Now, this approach makes the concept of a bootable partition irrelevant because it ignores the boot flag. So you change the code right in the master boot record, adding to the code if necessary in sectors 1, 2, 3, or whatever, and you basically do it that way. That's what Linux does. That's what Unix does. That's what FreeBSD does. That's not what Microsoft does. A note on boot sector virus. Suppose a virus contaminates the boot code. Not surprisingly, it's called a boot sector virus. It'll be executed each time you boot the computer. It may create a partition, put stuff in it, hide the partition, especially for Windows, making it something that the operating system can't mount. And then go on. Now, on the other hand, it's not hard to find. And so one of the things that any decent antivirus software will look for is that sort of stuff. So, let's look at a little bit more of the details of an MBR table. This is what's in the table. This is this is the data structure, again, in the listing value. I have the boot code. I have partition table entry 1, partition table entry 2, entry 3, entry 4, and then hex 55AA. This is a table out of Carrier's book. He identifies what's essential and non-essential. So, again, I'm going to go through this lab, and you can, my animation is crappy. I wanted to verify this, and I did. So what I'm going to ask you to do, and you can follow me through if you want to. First, you're going to go to your Forsyth lab. No, Radish NG. I changed this. So we're going to do this for Windows 10, and then we're going to do this for Linux. Now this you've probably done already, and so I'm going to open that up, and there it is.
So what is the 55AA? Not yet.
Here's 55AA.
Yeah. What about it? You said you're gonna tell us about it, but not yet.
I'm going to what?
You're gonna tell us what is that? What is that?
What is 55AA?
Yeah.
That's a marker that says that's the end of the master boot record, or a partition table boot record.
Is that considered little Indian versus big Indian? Is that it's transposed, and when you look at the signature value is AA55, but if you look at here, the address location is.
Yeah, well, everything is little endian here.
Okay.
And I will get to that when we look about these addresses, because we're coming close. Because, for instance, the LBA addresses and everything else are all little endian, because you got to switch them around.
Okay.
Now, but one of the other things I wanted you to do was also bring up Ubuntu. All right, I need to clean up around here a little bit. Okay. Okay, so, and if you remember the password, the login is student and the password is student if you have a problem there. I don't know whether I will have a problem there or not. No, it seems to like me. Okay, so now let me go back to this. It turns out there is a command, there is a piece of software in every Linux distribution. Well, first of all, there's DD, which we talked about. And DD has you can specify the path to the input volume, the block size you want to look at, how many sectors you want to skip, how many sectors you want to look at. So you can specify exactly what you want to look at. And then you can pipe this all to something called XXD, which puts it in a format that looks very much like what you have in WinX. So I'm going to basically highlight this so I can just copy and paste it later on, and I'm going to do a copy. And then I'm going to go back to, and I'm going to open up a terminal. Now, you have to do this all as sudo, but there's another way you can do it without sudo. I can say, I want to fork a new terminal called superuser, and so I'll do an su, but I can't do su because it'll tell me I can't do that, but I have to do a sudo su, and it says the password. And now notice my prompt is no longer a $, my prompt is a hash mark. That tells me I'm in superuser mode. Now then, I can do a paste, and this is the same thing I copied before, except now I can do it as superuser. And basically, what am I doing? I'm looking at a volume called SDA, and this is different than the same volume for Windows 10. A block size of 5 of 12. I want to look at the first sector. I want to skip nothing. I only want to look at one sector, and I'm going to pipe it to XXD. And then that gets piped to standard out, which is this display. And if you look, so here's the command. It says one record in, one record out. It then basically, it showed some stuff in here, but then continued on. And notice here's 55AA. And notice this is ASCII here. So XXD puts this in a format that looks very much like something like WinX. And you can do that. And it works very nicely. And so I just thought I would show you that because that's, and I also discussed the way you can, for those, a lot of people aren't familiar with Linux, and so I indicate there's, you can use sudo. You could have done the same command with sudo and it would have worked, but I put this particular terminal into superuser mode so that I don't have to keep doing sudo. We did this before. We did this again, and now they're going to be different because, of course, Linux has a different file system than Windows does. I mean, so you don't expect them, just because they're both on Radish, that doesn't mean that they have the same. But, so here is, and so this is what you got out of the WinX. And I guess the thing I wanted to show here was that that's the first entry, that's the first primary file system entry. That's the next one. That's the next one. And that's the next one. And then there's 55AA. Now let me back up a little bit. Notice that the first one has an 80 as the first character, which is really 08. And all the others do not in that first character. That 80 says the red one is a bootable partition. That's what Windows will use to say, okay, that particular partition, which is located as specified in the rest of this, that is where I will go to. Now, so this is what you got for the data structure of each master boot record partition. That's the boot flag. This is the starting CHA address. This is for 3 bytes. This is the partition type. It's non-essential, but it typically tells you what operating system is in it. There's ending CHA address, starting LBA address, and the size in sectors. So these two, this one, the starting CHA address and ending CHA address, and these two give the same information, except these two can't give large values. And so typically they're ignored today, and everybody uses this stuff. The LBA stuff. So if there's a hex 80, it's bootable. This bootable value is sometimes ignored in multi-boot systems. It's ignored by Linux. But it's used by Windows. Starting CHA address gives you some information there. It allows you to get to 8.1 gigabytes maximum using the heads cylinder sector information of the modified BIOS that we talked about last week. Partition type I'll discuss next. Ending CHA address, again, same thing as the starting CHA address. Gives me 8 gigabytes maximum. Starting LBA address tells me where to start, and I basically can get up to 2.2 terabytes. Operating systems decide which sector addressing to use. The last ones that I knew of that used CHA addressing were the Windows 95, 98 ME class of operating systems, which are long gone. And everything else uses LBA. And to my knowledge, unless you happen to run into a legacy system that's for some reason or other using it.
CNC machines.
Pardon?
CNC machines.
Yeah, right. So tell everybody what a CNC machine is.
I only have very basic understanding, but basically it's something that's doing mechanical cutting from a CAD design, basically.
Right.
And a lot of them are rather old at this point, and they don't want to pay to upgrade them.
And so
they're very expensive.
Yeah, but the problem is they're very expensive, and if it works, don't touch it.
And don't connect it to the internet.
So anyway, so that stuff is still around, and and it.
If you're interested in learning more about it, there's a bunch of really good YouTube channels about CNC stuff, and there's one of them making a replica of the Johnny 5 robot from Johnny 5. Lifetime.
So there's lots of there's lots of legacy stuff out there, is what I'm saying. Now, here's a little bit of comment that's partially mine and partially other people's as well, and that's sort of a mixture. Comments on updating MBR to accommodate larger disks. If the legacy CHA addressing were eliminated from partition table entries and MBR partition table entries, the capacity of LBA and partition size could be much larger. And in fact, you could make it 9.5 sextillion bytes. This plus extended partitions would handle very large disks. And this was and is one of the arguments for continuing to use BIOS and MBR and not going to EFI and GPT. However, EFI and GPT have gained acceptance, so both are used today, and to be honest with you, things are moving toward GFI. Well, they have moved to EFI and GPT.
It's generally faster too, isn't it?
Pardon?
It's generally faster too, isn't it?
Because you don't have to go through that chain of secondary partition tables and things of that nature, it gets you to a place faster, yes. It has a few limitations, which we'll talk about when we get to this, however. So both are used today, and some are used in a sort of a hybrid way, and we'll talk about that. Now, here's a list of some partition types and the numbers. So for instance, FAT12 has a number 1, NTFS has a number 7, Linux has a number 83, Linux swap partition has a number 82, things of that nature. So here's a list, and this is, I don't know whether this is in Carrier or not. It may not be, but I think at least part of it is. However, here is some of the Microsoft stuff and FAT stuff, which is sort of everybody's today. And remember, Windows uses the type field to determine the system and the partition. So, and there are things called hidden Microsoft MBR partition types. FAT hidden partitions have the same last hex value as their non-hidden equivalents. The first hex value is a 0 for non-hidden and a 1 for hidden. So FAT12 is 01, FAT12 hidden, CHS is 11. FAT16 is that pair. FAT16 CHS is that pair. FAT32 CHS is that pair. FAT32 LBA is that pair. FAT16 LBA is that pair. And so basically there's a 1-bit difference.
What about REFS?
Pardon?
What about REFS? Is that GPT only, or?
It shouldn't be GPT only, but I pulled this out of Carrier's book and he didn't get to it, so.
Sure, well, it's newer too. It's
Yeah,
11s and
it
7s
shouldn't
now
be,
as well,
it
too.
should not be. Yeah. Here's a partition table example from Carrier again. Now Carrier's example goes something like this. You have a dual boot, Microsoft Windows and Linux, 8 file system partitions. The tools used are DD, which copies a file or disk and converts and formats depending on chosen options, and XXD, which we already talked about, which can take input either as standard in or as a file. So here's the command line syntax. If the volume is disk3.dd, And the block size, I'm going to look at block size of 512, skip nothing, count of 1, and I'm pipe it to XXD. This is exactly what we did before. Now, the hashtag prompt here means that carrier is super user, which is exactly what I did when we went to SU. So let's say disk 3 is a file containing a previously bit-by-bit copy of an 80 gigabyte disk. So this is carrier's example, and again, one of the things I did was I color-coded some of the stuff, and so it makes it a little easier to read. So the block size of 512 is meaning it's one sector in this particular case. I don't skip any sectors before starting. So I'm only going to read sector 0. I'm only going to read one sector, so the count is 1. And I'm going to pipe it to XXD, and XXD outputs the standard out, which is my command line, my terminal output. So here we have DD, input file of disk 3. Remember, that's the whole volume with all this stuff. And rather than include all the code, all the 512 bytes, not 512 bytes, but 400 and some odd bytes of code, I'm going to skip, that's removed. And basically, these starting here is my partition table. My master boot record partition table. So basically that command gives me this. And if you interpret that, this is a hard disk read. Hard disk read. So this is the boot code. So this is the partition table entry 1. Is there a bootable part? Is there a bootable file system in that partition?
No?
No,
Yeah, shouldn't.
because there would have to be an 80. That's the boot flag, which is nothing. It's a null. That's the starting CHA address. This is the partition type. Partition type is 7. That means NTFS. That's the ending CHA address. That's the starting LBA address. Little Endian. And that's the length and sectors, Little Endian. This is the next one. And again, I'm going to go through them all. And this is the third one. The partition type is a Linux. Let me back up one that I skipped that kind of. Partition type was, it's bootable. So you're going to boot out into Linux file system here. That's another Linux file system which is not bootable. And what is that? Well, the 5 says that's an extended partition. So, this is the contents of the NTFS partition and 2 Linux partitions. So these are the 4 entries, starting sector, etc. So let's look at that a little bit more detail. That's 80. That means it's bootable. That says 07 is NTFS. That's Linux, and that's extended. Now, so what we have is this. We have this volume. We have an NTFS partition starting at 63 and going to this hex value, which is 2056257. And that's the size, okay. And then if you look at the primary extended, you will have this number. Oh, I know, it's on the next slide, sorry. I was looking for something that should be here, and it's on the, it's a couple slides from here. So, but notice that this extended partition has a size of 76,999,545, which is this number. And it starts at 3,293,325, 3,293,325, which is right here.
But why they put the end by 80292,869?
I don't know what are you asking?
Yeah, you see here they say like, oh, calculation of this two.
Which one are you talking about?
The last one,
This one?
Yeah. Size is 80 from 3 million, something like that, to 80. Yeah?
3,293,325. 3,293,325. That's the starting sector address.
To 80. It's close to 80.
I don't know what you're
That,
asking.
in the image, you see the 80 there.
80. Oh, here.
Yeah.
And why is this 76,999,545? Is that why you're asking?
Yeah, I think it's minus of the one before.
No, because this is the size. This is not the end. This number is this number. This is not the starting and end. This is the starting and the size. A little bit more on extended partitions and details as an aside. The first sector is an extended partition, and this is here's another problem you run into, and you're going to run into this. The first sectors of an extended partition have the same data structure as the MBR, but it is used differently. It is used to create a linked list. Now, here is the problem. Starting addresses for the secondary file system entries in the extended partition table are relative to the beginning of the current extended partition. While by contrast, starting addresses for a secondary extended partition entries are relative to the primary extended partition. Now, what the hell does all that mean? So this is confusing. So let me read it again. The starting addresses for a secondary file system entry. Secondary file system, not extended. In the extended partition are relative to the beginning of the extended partition in which the file system resides. By contrast, the starting address for a secondary extended partition entries are relative to the primary extended partition. That means their starting points have a different place for starting, which is a bit of a pain. So I'm going to go over it again in a couple of slides, but I wanted to just highlight it here. A primary extended partition must have a size capable of containing the partition table record plus all of the secondary file system partitions plus all of the secondary extended partitions. A secondary extended partition must have a size capable of containing the partition table record plus the next secondary file system partition. It does not need to contain further partitions. Well, that's another kind of a messy thing. So here's an example which talks about that. Here I have a primary file system partitions here, and I have a primary extended file system partition. So let's look at that primary extended file system partition. And this is right out of the book again. So notice that this primary extended file system partition all yeah, okay. I thought I got myself into trouble for a minute. I got to go on a little bit before I talk about this. So basically I have a FAT, an NTFS, and ext3 file system, and another FAT file system. And there's a little space between them. Now, if in my primary file system partition, I have two entries. One starts at 63, and the length is 3937, and is a FAT file system partition. Well, if you take 5,000 and you subtract 1,063 from it, you get that number. And then I have another one that starts at 4,000 and goes to, and it has a length of 2,500. Now, and that's the extended file system partition. And this is what is in the FAT primary extended file system. So this is not in the, this is not here. I perhaps positioned it badly, but the idea is it's what is in the FAT here. So it is what's here. And it starts at 63. FAT starts at 63. It doesn't, notice it doesn't start at 0, it starts at 63, which is 63 from 1,000. So it's relative to the beginning of this extended partition. And the extended partition starts at 4,000, which is 5,000 minus 1,000. And the length is 2,500. Now, let's look at the next one, the NTFS one. The NTFS one, again, the file system starts at 63. And the extended starts at 6,500. So the extended starts at 6,500. Which is 1,000 less than, let's see, where am I here? Oh, it's the length, 65. It starts at 6,500, which is 7,500 minus 1,000. So it's relative to the beginning of the primary extended. So one starts at the beginning of this extended one. The file system starts at the beginning of the extended one, but the extended partition that follows the file system starts all the way back at the beginning of the primary. And likewise, this one, and likewise that one. And so the idea here, and notice here I don't have anything at the end because I don't need another extended. The point I'm trying to make is that the sector address, the beginning of the sector address for the start of the extended partition always refers to the beginning of the extended partition which contains it, while the file system always starts at the beginning of the extended partition that the file system is in. Messy. It's okay once you sort of get it in your brain, and if you're writing code, you'd get it wrong the first time, and then you get it wrong the second time, but by the third time, you get it right. And it's a bit messy, but nevertheless, that's the way it is.
Isn't the 63 is the size between each one and another? Because you see in the from 1,000 to 1,063,
Right.
and 5,000 to 5,063.
Well, that was just put in here because there's some empty space here.
It's like 63, yeah?
These are the 63 sectors that are always reserved. So that's why those 63 are there. Remember, there's always 63 sectors. After the master boot record, there's 63 sectors that are reserved. Well, after an extended partition boot record, there's always 63 sectors reserved. Just like the master boot record, except it's not the master boot record. So going back to this example, here we have, this maybe clear things up. Here we have this example I had before. And let's look at the primary extended partition table. So this is the primary extended partition table. This is one of the blue guys. And there's the partition table at the beginning of the primary extended partition table. So if I do this command and I skip 3,293,325 and do a count of 1, so I basically want to look at this entry. I only want to look at that sector, so I have to skip this bunch. Then what I get is this. This is what I get, and I'm color coding these for a reason. So I get a type of 83, which is a Linux, and then this is an extended partition with these numbers. And if you look at that, the flag is 0. That says I'm not going to boot anything. This is hex 83, which is a Linux file system. This is the starting sector, and now notice that the starting sector in hex is 00000003F, which is different than this because this is Little Endian. So it's entered in Little Endian, so you have to switch it around. So you have to move all the zeros to here, move the 3F to here, and then move the 00 and the 3F around within themselves in order to get this number. Likewise, you have to do the same thing here. Now, that's okay. You write a short piece of code that does this, and it's 4 commands, and you churn it, and you keep using it, and it does it all. Similarly, that's also not bootable, but it is an extended partition. And again, we have the little endian, little endian issue. And we have that. That's Linux, and that's extended. Now that's relative to the start of the current partition table. And that's relative to the primary extended partition table. So you have that same problem again. It's not a problem, you just got to be aware of it. They start at different places. Now, I can understand why they might have done this. They might have done this because if I want to chain down a whole bunch of extended partition tables to find out something, it allows me to move through that faster than if I don't do it. And so I can always refer back to the original, and that may help. By the way, there's an error there. This 572 should really be 512. Some of you may have it fixed, and some of you may not. When I found it, I sent a message to Brian Carrier saying that's an error, and he said, "Oh yeah, I'm gonna have to fix that." And I've seen it fixed, but I haven't seen it fixed, so I don't know. My book, which is an old book, has it wrong, but anyway, it's an error. Remember, a primary extended partition must have a size capable of containing all of the secondary file system partitions, plus all of the secondary extended partitions. But a secondary extended partition has a size that is has the size of the next secondary file system partition plus the partition table record. So here, if we have this sort of situation again, and I look at this, again, the same example, the Linux partition and the extended partition, and I fix this again. This is the primary extended partition, but this is the secondary extended partition. And so this is 63 sectors, starting there. And then this is relative to the start of the current partition table, and this is relative to the primary extended partition. And so again, you have that same problem again. So that's 5.124.735. That gets me up to here, etc. So you're going to have to look at that and sort of think about it a while, because those numbers, until those numbers soak in a little bit. A couple of partition viewing tables, and we'll talk about those a little bit. Tools, rather. A number of tools can be used to determine and view disk partitions. Some of the tools can only view partitions on a disk. Others can view and modify. Carrier discusses two tools, fdisk for Unix or Linux. This is not Windows fdisk, as you remember I said. Well, by the way, Windows 10 no longer has fdisk. Windows 7 and Windows 8 had fdisk, but it wasn't worth anything, so why? And then there's MMLS from the sleuthkit. So there's some other tables. There's a forensic toolkit, which we aren't going to use. Hex Workshop, which is a free sort of thing that does a lot of the stuff that WinHex does. Not as fast, and it's not quite as good in my opinion, but it's free. There's Windows Computer Management, snap-in, I don't know why they call it a snap-in because it's always there. Unless I snapped it in at some point in time and never got rid of it, but
Yeah, by default, you have to add it to MMC.
I don't recall ever doing it. It was there, but anyway, okay. And then there's things like Partition Commander and Partition Magic, which extend into the sectors 1 through 63 that allow you to do fancy stuff with multi boots and things of that nature. Now let's look at FDisk a little bit. FDisk comes with all Unix and Unix distributions. FDisk doesn't exist in Windows 10. If you have FDisk in an older version of Windows 10, don't bother. It doesn't do much. FDisk command to retrieve volume partition is this. It's FDisk LU and then the name of the raw image file. And I'll go through this in an example. The L lists the partitions, but doesn't allow editing, just lists them. So you don't want to screw with it. And U shows the LBA sectors instead of CHS sectors. In Carrier's example, you have FDisk, and it shows this. And you notice you have all these disk images, and some of them are Linux, and some of them are extended, and et cetera, et cetera. Now, the block sizes are the plus there implies that it's the block sector divided by 2. So that plus indicates you got to multiply by 2 in order to get the actual sectors. Now, I'm labeling these 1, 2, 3, 4, 5, and 7 for a reason. This is primary, extended. Number 6 is missing. And number 8 is missing. And I'll talk about that in a minute. Because FDisk does not show secondary extended partitions. So it shows the stuff that's the file system, it shows all the file system partitions, and it shows the primary extended partition, but it doesn't show any of the secondary extended partitions.
Your numbering is just based on start and stop address, and the address is, you know, they're contiguous or whatever? How do you figure out 6 was missing? Because you numbered them yourself.
I'm trying to remember how I figured out 6 was missing. Actually, I think the way I figured it out missing, and I'll show you in a minute. So you're not seeing all the partition table entries. But
That's what I thought.
now let's look at MMLS. And that's why MMLS is really pretty good. MMLS yields all of it. So MMLS basically says you have to tell it the type, and in Brian Carrier's terms, this is DOS, and then the name of the raw image file. T must define the type of partitioning. DOS defines basic MBR partition. I'll show how this works with Windows 10. And basically, this is the command you use to do it in Windows. But I'll do that later. And it assumes DOS if you don't tell it otherwise. So here is MMLS list. The start and end lengths are in sectors, which is nice. You don't have this multiple factor by 2. All partition tables are located. So notice 6 and 8 are there. And they are identified as extended. Now, I don't know why FDIS doesn't do that for the secondaries, because the information is there. You can just look at it, but they don't. So table 0 is the master boot record. Here's table 1. These are all the, here's table 2. So you actually have the tables that you can go and look at if you want to. The slot syntax is partition table, entry in table. So here is the partition table 0, the entry in the table. Isn't that nice? Here's partition table 1, the entry in the table. Partition table 2, the entry in the table. So it's really is nicely laid out in the context of the extended partition tables. Partition types are shown, etc. Unallocated sectors are shown. So if there's something that's unallocated, it's just a bunch of dashes, and it says, well, you know, and these are the tables because the tables are really unallocated in the sense that they're not part of a partition, and it's only one sector long, but that's where the table is. Now, it doesn't show which partition table has bootable flag set. Why would you suppose that's the case? Well, I don't know why that's the case either, except that MMLS was written. Brian Carrier was a Linux guy. He was a Unix guy. He wasn't a Windows person. And so consequently, bootable flags were not something he was particularly keen on. That's my guess, but that's a guess. Also, MMLS, to be honest with you, couldn't do this if it used bootable flags. So it sort of has to ignore them. Okay, now before I go on, I want to, and we'll take a break in a minute, but I wanted to do a few things. So first of all, man. That's interesting. Probably fat figured something. There we go. Okay, so if I do a fdisk minus lu minus dev sda, I guess I can, dev would be wrong. Lu, what did I do wrong there? Fdisk minus lu slash dv dash sda. Okay, so this is what I get. I'm looking at the one partition that is there for this Linux system. Well, actually, it tells me something about the disk size and a few other things as well. If, however, I do an MMLS minus T DOS slash dev dash sda, I get this, which gives me a bit more information because it gives me the unallocated areas, which are the tables. Now, let me go to the Windows, and I'm just going to close this up. And I wanted, let's see, there was two things I wanted to do here. Oh, I know. I want to open the command prompt as administrator. Now I'm in Windows. And if I do open the command prompt as administrator, no, I don't want to do that. Well, let me get rid of this. What I want to do, let's see. I'm sorry, I'm in the wrong operating system here. I did want to do that. Want a command prompt as administrator. And then what I want to do is to where do I get that from? My apologies. I thought I had it. Oh, here it is. I didn't want to do that. Sorry, I want to run the SoothKit as an administrator. Now this puts me in the SoothKit binary file, and then I can run an MMLS from this. LS minus T DOS. And then so this gets me to where I want to be, but I have to define what I want to look at, and the magic keyword is and I get an MMLS, and MMLS runs just fine. And so this shows you the physical drive, and this will show you in Windows what I get with MMLS. And MMLS gives basically says I have two NTFS partitions. One of them is for the D drive, which thou shalt not touch, and one is for the C drive, which we can fool with. And then there's an unknown partition type, and I can't remember what that was, but so these are both NTFS. This is the primary MBR table, and these systems in Radish are all bootable. They are BIOS run. They are not EFI run, which we're not talking about yet. All right, so that's one thing I wanted to show you. I want to show you one other thing. This is now back on my machine. And if I open the SoothKit batch file as administrator. Now this is on my machine, and I can do the same thing, MMLS minus T DOS Now notice the difference, and we haven't gotten there yet, because I'll come back to this later. my machine has a GPT rather an EFI rather than BIOS. And so basically it says there's a safety partition, the NetBIOS safety partition, and it says, okay, it's there. And other than that, there's nothing for NetBIOS. Now we're going to talk about that in a few minutes. Get the reflections. Is that 5 after 8?
Yeah.
Okay. So we'll talk about that in a minute, not a minute, but in a few minutes. And then we'll come back to this, and I'll show you how to. We can look at. Actually, I can show you right now. If I go back here, and instead of I type as DOS, and instead of that I do EFI, which means that it's the other type I'm going to talk about in a minute. GP, it has to be GPT, sorry. Now I get an MMLS that looks kind of more information, but because it's interpreting things with this new system, that it's not all that new anymore, but it's a new system. All right, before I go into that, why don't we take about a 5 or 6 minute break? I need a drink of water, among other things, because I'm losing my voice. And then we'll come back here, and then we can finish up by 9 o'clock. All right, I'm going to David, I'm going to quit streaming, but I'll start streaming again, unless you don't want me to. I'm going to quit streaming and then start again in about 10 minutes.
Yeah, that's fine.
So it's easy, but I want to need to approve before I write. This is the thing down. Right? Oh, and then
Okay. What I want to do start is, now we've talked about master boot records ad nauseum, and I want to talk about GPT, which is the way things are pretty much going today. Although, as I said, for legacy reasons, you run across all this other stuff that's old. And a lot of what we talked about in MBR will be applicable to GPTs as well. Okay, so we've discussed that. And as I said, the booting and partitioning scheme has been very widely used since, well, maybe the companion software with basic MBR is called BIOS, the Basic Input Output System. And that's been around forever. The basic MBR had limitations that had mostly been overcome, but about the year 2000, another schema was produced, or was proposed, that overcame many of those limitations. They came up with something called a Globally Unique Identifier Partition Table, or a GUID partition table, shortened often to GPT. Or if you were global, I guess, partition table. Anyway, but that's the term. Now, there are some other terms that are used as well, and I'll talk about those as well, because you don't always find. You can Google GPT and that works, but there are other things that don't work. It's a newer partition scheme. It began around the year 2000. It was first used with IA64 and x86-64 UEFI systems. I'll talk about that in a minute. The IA64 was the Intel Itanium-based system. UEFI stood for Unified Extensible Firmware Interface. And the idea was to, the plan, I'm sure, in Intel's mind was to make everything do it this way. And now, UEFI is often referred to as EFI. They drop the U. On the other hand, in a lot of places, if you Google EFI, you don't get quite what you want, and UEFI works better. So, now EFI is used in place of BIOS. And the GUID or the UUID, the Unified User ID, is a globally unique identifier or universally unique identifier that is part of the EFI system. It's a 128-bit number, and the goal was to uniquely identify something like a volume. And because it's a 128-bit number, you should be able to get 34 billion trillion numbers out of that. And you'd think that would be enough. Well, let me tell you a story. Let me tell you 2 or 3 stories. The first machine I had had 2 floppy disks in it, 5 1/4-inch floppy disks. One held the operating system. There was no mass storage other than the floppy disks. There was RAM, and each 5 1/4-inch floppy disk held
11 meg.
No, it wasn't anywhere near that.
It was 1.1 meg.
You're right. It might have been 1.1 meg.
I got
Okay.
asked that question on Saturday.
Okay.
It's
All right.
1.1 meg.
11 was way too big.
That's the smaller floppies, and we have a hard drive that's 11 meg.
Yeah.
So things like that. Things.
Yeah. So it was the floppy was a 5 1/4-inch floppy, which floppy disks were actually invented by IBM as being a way of getting some firmware into something, or you carry a little bit around. Well, anyway, that's what was on it, and so you had about a megabyte and there was 2. One was for the operating system and applications, and that was a megabyte, and the other one was for data, and that's what I had. And everybody thought that was a lot. Well, it wasn't a lot, and everybody thought 4 partitions was a lot, and it wasn't a lot. Now, when I chaired IEEE 802, one of the things we had going for us was a 48-bit MAC address, which was a lot larger than 32-bit IP addresses, and we had MAC addresses. And people started to want to use them for unique identifiers. And for a long time, when I was chairing 802.1, we would get requests from typically companies saying, we'd like to have a reserved set of MAC addresses for our hardware. There was a guy named Vince Condello at the IEEE who would basically take these requests and send them to me, and then my committee would decide whether the person was worthy enough to get a group of addresses. But 48 bits wasn't enough after a while either. So one would say, well, geez, a billion, trillion, especially 34 of those billion, trillions, that's almost as much money as Michael Bloomberg has. And that might be enough. Well, I don't know, but every time I've heard something like that is an argument saying this is enough, it ends up not being enough. So I don't know. GPT and EFI. GPT can be used to boot the following operating systems if the firmware used EFI, not BIOS. BIOS doesn't know what the hell to do with GPT. FreeBSD in most Linux system distros will support it. Vista, Win 7 and upward using x86-64 and EFI will support it. A lot of Windows servers will support it. Mac OS from v10.4 onward will support it. GPT cannot be used to boot any Windows operating systems or Mac OS 10 from a PC that has BIOS firmware. You gotta use EFI firmware. Many systems are now hybrid. They boot either using BIOS or EFI. BIOS has, in many cases, taken precedence, but that's been changing. EFI has some criticisms. One of the criticisms is that it was overly complex without adding value. I don't know that that's a legitimate criticism, but that's a criticism that's you see. Now, the number of partitions is limited to 128. Now, again, that's one of those numbers I look at and I say, well, yeah, but maybe. However, I don't know. Do you know whether this has recently been changed, anybody, from 128 to something else? I didn't bother to look, and I'm not sure. Anyway, currently it's limited to 128. One of the nice things, although the complexity it adds is messy, about the BIOS system with extended partitions is that you could go on forever with some cost. If BIOS and MBR were updated, they would be adequate, but they haven't been because they can exceed 128 partitions. Here is what GPT drive layout looks like. So here I have, and I shouldn't say drive. You know what? Let me change that. It should be volume. Okay, so here is the GPT volume layout. So you have LBA 0, that's the good old LBA 0, which has a protective MBR sector. It has a master boot record, it has all the other stuff. It prevents MBR-based software from overwriting GPT, which of course would be a disaster. And it's hybrid because it allows GPT booting that can start in the master boot record. And that's indeed the thing I showed you a little while ago was exactly that. The GPT header, which starts in LBA 1, is the primary GPT header. And what it does is it identifies the usable logic blocks that can be used for GPT. It defines the number of partitions on the drive. It defines the size of the partition tables, not the partitions, but the partition table. So I can have a number of different partition tables. And it reserves space for up to 128 entries. Each entry has 128 bytes. And it has a GUID or UUID, which is a universal identifier in that one of billion, trillion numbers for the entire volume. That should be volume. The partition table area, which starts in LBA 3, to LBA 33, contains the actual partition table entries. And then the partitions themselves start in LBA 34 and go to some maximum number minus 34. And then the other thing at the other end, which is fairly smart actually, because one of the problems you have with MBRs was that if you lose the MBR, you're in big trouble. And so they have a duplicate of everything, just a mirror of this in reverse. So the green stuff slashed and the blue stuff slashed, or one is a mirror of the other, in case something goes wrong. So here's a kind of a comparison of MBR and GPT, layout comparison. This is the MBR drive. You have the master boot code, the 4 partition table entries, 55AA. Then you have the partitions, and you have extended partitions. We've already talked about that. In the GPT disk, you have exactly the same stuff is the protective MBR. And then you have a partition table header, and then you have a bunch of partition table entries for up to anywhere between 1 and 128. Then a bunch of partitions, each one defined by one of these entries, and then a repeat of the stuff up at the top. So here is a protective table MBR. Now notice this is a standard MBR. There's 55AA here. Here are the 4 entries. And if the first entry has an EE for the type, partition table type, or the file system type, that says that it's a GPT. And these other numbers I'll talk about in a minute. They basically all ones here basically says to the end of the drive. And there's 55AA, so this looks like an MBR. And then you have your first EFI partition starting at the beginning of sector 1. There's no boot code in the MBR. This is all empty. And this basically says you really have an EFI system. So, well, we already talked about that before. And this is these are the things you would get if you had an EFI system. Basically, there's no bootable flag. There's a starting CHA address, and I'm not sure how to interpret that number, but it seems to always be there, and it's either 512 or 8192 base 10. Partition type, that's the EE, that means it's a GPT drive. All one means it's the end of the drive. Starting LBA address, little endian starts in LBA 1. And the size and sectors is all ones means it's the end of the drive. All right. So let's look at the GPT header. So here's the GPT header. This is of an EFI partition. And you'll notice this highlighted part here basically says EFI part. It says EFI partition. So this is now in the first sector, not the 0th sector anymore. It's in the first sector. Here's 55AA, which means you just got through with the boots, the MBR boot sector. Notice at the end of this sector's 55AA is gone, never to return. I'll come back to this and some of those things. Well, actually, so that's the information about the EFI partition, and we'll talk about what some of those numbers mean. So here's what they mean. This is LBA1. The first 7 bytes it says EFI part, which is EFI partition. Then 8 to 11, 8, 9, 10, 11. This is a version number. 12 through 15 are the header size, usually 92 bytes. 12 through 15 are the header size. And for some reason, oh no, it's here. 12 through 15 is header size. And so this has to be little endian, so it's 0000005C. And that should be 92 bytes. There's a CRC of the GPT header, which is a good idea because of the fact that if the CRC is corrupted, then something is screwed up and you had to go back to the copy down at the end of the volume to see what's wrong if you can. There's a reserved area. The large block address location of the GPT header tells you where it is. It tells you where the backup copy of the GPT header is. And a bunch of other things. And I don't want to go over these, but you can look at them. But these are the things that are in LBA1. So they are the things that are in that shaded area. Now the GPT partition table looks like this. Now there's a partition. This is 4 of the 6 partition table entries are shown. So there's an entry for each partition, and there are going to be 6 entries in this particular case. I'm only showing 4 of the 6. And you notice there's points for a comment here. So this is an EFI system partition. Here's a Microsoft reserve partition, and here's a basic data partition, and another basic data partition, et cetera, et cetera.
Now, are those standard comments or are they user generated?
They're user generated. Well, some of them are sort of by custom standard.
But it's not something where, like, if you were to change that, it's going to screw
No,
up.
no, that's the user generated. I mean, I guess by custom, something called a basic data partition is probably something that, you know. So, all right, so this sort of explains what those attributes are, and I didn't color code them on that, sorry. Oh, actually, I did. Sorry, okay, so here we have the partition type as a GUID, unique partition type as a GUID, which is this number. Now, this is the number that is unique in the world or in the universe or cosmos or whatever you want to call it. Then this is the first LBA of this partition in Little Endian. And this is the last LBA of this partition in Little Endian. There are attribute flags here. And here's interesting, good old 80. Again, Microsoft won't get off of that, I guess. And then here is the partition name. It can be up to 36 UTF-16 characters, and it can be anything you want it to be. But there are some, if you look, there are some customary things that are said. Now, and then we're done almost. So if you installed Windows 8 64 and beyond, you were going to be, and you were going to initialize, you would get some message that looks like this, which says, do you want to do MBR or do you want to do GPT? And I've run into this a number of times when I've put in when I've switched from a rotating hard drive to a solid state drive. And I don't even know whether they have that warning anymore, but the last one I put in, which was the time after I did this one, I copied this one off, was basically they were out telling you that, not everything will work with this. But we're moving toward GPT. So and that's it. Now, before we finish, I do want to again go back to now this is on my personal computer, and I'm going to run this as administrator. And just so you refresh your memory again, if I did an MMLS and I told it was a -T DOS, meaning I wanted to look at the master boot record, the MBR. And then I did a and then basically it says there's a GPT partition, and there's hex EE partition type. And so that tells me this is the protective boot record. It means if I were to run BIOS on this thing, I get that, and it won't do anything else. But if I do this, and I tell it the type is GPT, then I see that I have basic data. I have 3 basic data partitions, which I do on this machine. Actually, I have 4. I have 3 basic data partitions. I have a partition table. I have the safety table, which is the MBR table, and this is the same MMLS information that I had before, and this works reasonably well. Now, one other thing I'll mention, let's see, I want to run command prompt as administrator. And then what I'm going to do is I'm going to do computer management. Trying to think of what is this. What's the switch? S, C.
Oh, for this management? I was just going to turn C.
That's what I wanted. And I can So there is a disk management system that you can bring up, and you can also just bring it up here with computer management. If I did a COMP, that would bring up the same thing. And as you can see, it tells me that I have a removable disk and I have a basic disk, which is my solid state drive, and this is what's going on. And so you have a GUI here, which is much like the Gparted and the GPT, not GPT, but the Gpart and the Gparted that we talked about last time, which is available on Windows. That works pretty nicely as well. There are some things you can't do with it, and you don't have to assign letters necessarily. And this is the thing that they always say you got to put a snap in, and I don't ever remember putting a snap in, but it's here. So.
That's if you open it through MMC.
Ah, okay, that's why. Okay, all right. Okay, so actually I'm done. And are there any questions about any of this so far? I have an assignment that I will post tomorrow. It has a few rather interesting questions in it. And I'll let you guys figure out. There's a couple of them that are a bit of a challenge. Only because you can't, it's hard to test them out. Anyway. Yeah.
I just had a question on the assignment 5. So I was reading it, and it seemed like the first question didn't require a table, but the second one did. But in the instructions, you put a table for both. I just wanted to clarify.
Well, let me look at assignment 5.
So the first one seemed more to just answer a question, versus the second one was actually create a table.
Well, it says for 051 and 052, create a small table.
Right, for 1 and 2. I don't believe 1 needs a table, because it's more like answering a question. But the second one does require a table.
Well, but the table you could put the number in there, I guess. That was my thinking.
Do you want us to answer with a table, or?
Yeah, put them both in the table. It just makes it easier to grade.
Oh, okay.
I already submitted, and I just had 5-1 with the answer, and then 5-2 with the table.
Yeah, I did the same thing. So wouldn't that just be a border otherwise?
Yeah, the
Just
table
a
doesn't make
number.
sense to me.
Yeah.
Like for one, it sounds confusing.
It's interesting.
Because by 2, you've got, it's a 4x2 table, right? So that makes sense. But for question 1, it's just an, yeah, 4.
But it does say 4051 and 402. But
Yeah, well, so the way that I viewed it is it's a 4 data row table with 3 items for 5-2.
that's true.
The 3x5 if you're going across and down, and 5-1 is literally just a single entry. So it's just a question.
But the question has a number answer.
I answered in a sentence.
Okay.
Yeah, so did I. I wanted to make sure that's what you wanted before I submitted.
Yeah, I mean, what would go in the other columns or rows? It's just. I mean, I can resubmit it with it, but it's just going to be border around it.
Everybody I've heard from online is just like, yeah, I'm only going to do one of the table for question 2 because it didn't make sense to them. So.
The interesting thing about that is, I think they actually used this question in last year, and I never ran into the problem.
I mean, unless we're misunderstanding what it's asking, are we like on the wrong track?
No, well,
Okay.
I don't think, I hadn't looked at them yet, but I don't think you are. I'm in the process of grading the assignment before this right now, about
Sure.
a third of the way through it.
Yeah.
I hope to have it done tomorrow, but anyway,
So, shall we submit with just a sentence, or do you want us to do the table first?
if you haven't done it yet, put it in the table. If you have done it, I'm not gonna, I don't wanna mess around with it. So anyway, if you haven't done it, please put it in the table. If you have done it, okay, then don't, then you didn't. I'll only take about 50 points.
I guess, just to clarify, what would the table include? Like, how would you want it structured?
Well, says, create a small table with the list of tools vertically at the left and HPA and DCO across the top, and fill in the table with yes or no answers.
Yeah, that's for 2, but. you're
For
asking-
one, it doesn't, yeah.
Oh, I see what you're saying.
Yeah, I know for 2, I mean, that's clear, but for 1, you're saying create a table for 1, which, that was my question, is how do we create a table for 1? So that one is just answering your question.
I don't know. If you don't want to do it that way, that's okay then. Then leave it alone, or just put your answer in. But I do want the numerical answer.
Oh, yeah, no, I have the numerical.
Yeah, I mean, it's not hard to do. I mean,
Yeah, I just didn't know, like, how to put it in a table, or, like, how to format it.
well, that's true. The way I define the table, you can't do it that way,
Right,
because the only entries are yes and no.
Right.
All right, I guess I changed my mind.
Yeah,
Fine, leave it separate.
Yeah, that helped, because I was really trying to figure out number 1.
Okay,
and how-
sorry.
Yeah, I honestly didn't even catch that. I just reread that, I'm like, oh, that's just.
Yeah, I thought it was a typo too, because it made sense for 502. I was like, I don't think we meant 501. Because it didn't. I was like, how do I put this in the table?
Okay, don't put it in a table.
Thank you, sir.
You have a point. Any other questions? Okay, stay warm.
You recommended, like, readings for next class, that you always have to include in the assignment.
I'm sorry, what?
Is there any recommended, next readings for next class, or is that gonna be included in, what will be in the assignment? The assignment will tell us what to read next, or what you would like us to read next.
Given that the exam is going to be week after next, that's probably a good idea. Would you please send me an email, and I will make sure I get that out tomorrow.
Okay.
And I will definitely give you the reading. It's basically the FAT and NTFS file systems.